So hello students, today we see some problems based on ionic product of water. Okay, an ionic product of water in different aqueous solutions of different salts. Okay, see the first one. So at 25 degrees Celsius, it is given that dissociation constant of NH4OH. We know that NH4OH is a base. Dissociation constant is given means the given is Kb. Kb is given how much? 2 into 10 to the power of minus 5. If the molar concentration of the base is 0.2 m, means here the concentration is given 0.2 in terms of molarity. We have to find the proton concentration of its aqueous solution. Mean proton concentration means we know that proton means nothing but H plus and concentration. I have to find this. These are the given details. So already we know NH4OH is a weak base. So actually, how to find out the H plus? Here it is given the concentration of base. Nothing but the concentration of OH minus is given. But the base concentration directly not taken as the OH minus concentration because NH4OH is a weak base. For example, if in the place of NH4OH, if it is given sodium hydroxide, directly we can take the OH minus and concentration equal and the OH concentration. But we know that NH4OH is a weak base. For weak bases, we know the formula OH minus equal to. So actually, which formula we want to calculate it is Kw equal to H plus into OH minus. We want to get H plus. This is the problem. So what is the formula? Kw by OH minus. So we have to find this H plus. We know that Kw at 25 degrees Celsius it's a constant. What is the OH minus? It means to calculate the H plus we must know about the OH minus. If in the place of ammonium hydroxide place lo manaku sodium hydroxide ichunte so direct ga OH minus place lo sodium hydroxide concentration rastulam, but it is a weak acid, so weak acid ki direct ga base concentration equal not OH minus concentration equal not directly base concentration. Weak bases ki degree of dissociation less kabatti we have a separate formula for them. So we know that NH4OH is a weak base. How to know it's a weak base means if it is given Kb value, so automatically we can say it is a weaker one. Okay, NH4OH is a weak base, so therefore what is the formula? OH minus is equal to, it's a base kabatti base dissociation constant Kb into C. Okay, now substitute the values in it. So therefore OH minus equal to what is the Kb? So Kb value given 2 into 10 to the power minus 5. What is the C? Whatever the C concentration is given 0.2 in terms of molarity, there is root. So just for simplification, so root 2 make it also 2. Okay. So finally we will get OH minus equals, so 2 means on the root removal of root we will get 2 only, and for minus 5 minus 1 minus 6 on the removal of root we can say 1 power 1 by 2, that is 10 to the power of minus 3 molarity. Means we got the concentration of OH minus. Now substitute in equation 1. So 1 implies, we know that H plus is equal to Kw. What is the Kw value? We know that at 25 degrees Celsius, it's minus 14 moles square per liter square. OH minus concentration, how much you got? 2 into 10 power minus 3. It's M means moles per liter. So 1 by 2 we can say it's 0.5. Minus 14, here we get to minus 11. Okay. I think so we can say so it is for minus 10 moles per liter. Okay. Okay, see the next it's an important model. So the concentration of hydronium ion. So okay, see, so third problem, it is given at certain temperature the proton concentration of pure water. It's important, the pure water is 2.5 into 10 to the power minus 7. So what is the hydroxyl ion concentration? So actually there is some problem is there. Though what is the Kw value is also given in the question. Okay, so we have to find what is the hydroxyl ion concentration and also what is the value of Kf. So what is the value of Kw? So here important thing is that it is given pure water. So what is the nature of pure water? The nature of pure water is neutral. Water is neutral in nature. Neutral in nature means the H plus concentration is exactly equal to the OH minus concentration. So pure water given, so nothing but it is given that H plus concentration is equal to OH minus. So only the proton concentration H plus is given. So therefore we can write OH minus. Hydroxyl concentration is also 2.5 into 10 to the power of minus 7 moles per liter or M. Because H plus equal to OH minus. Already it is given H plus equal 2.5 into 10 to the power of minus 7. So you got the one answer, that is the hydroxyl ion concentration. So find the Kw. So you know the Kw formula at any temperature. Okay. So Kw equal to, this is second part in the problem, H plus into OH minus. What is the H plus? Same, 2.5 into 10 to the power of minus 7. What is the OH minus? Same, because both is a pure water, so both are equal. So moles square per liter, this is moles per liter, this is moles per liter. So finally we will get 2.5. So exactly we got 6.25 into 10 to the power of minus 14. It is moles square per liter square. Okay. Means we can say if the temperature is less than 25 degrees or greater than 25 degrees, compulsory we can say its temperature is more than 25 degrees Celsius. Sometimes the question may be like this, what is the temperature? So exactly we cannot calculate the value of temperature, but we can say the temperature is less than 25 degrees Celsius or more than 25 degrees Celsius. Because we know that as temperature increases, Kw also increases. As temperature increases, Kw increases. At 25 degrees Celsius, what is the Kw value? 1.0 into 10 to the power minus 14 moles square per liter square. So in this question, finally we got 6.25 into 10 to the power minus 14. So it is greater than 1.0 into 10 to the power minus 14. But automatically we say, directly we can say that its temperature is more than 25 degrees Celsius. Okay. So next, see one more problem. So calculate the number of hydronium ions. Calculate the number of hydronium ions present in 10 milliliter of pure water. At 25 degrees Celsius. So here the temperature is mentioned. So we know that, see the problem. Calculate the number of hydronium ions present in 10 milliliter of pure water at 25 degrees Celsius. We know that pure water is a neutral in nature, H plus equal OH minus, and their concentration equal to 1.0 into 10 to the power minus 7. Each H plus equal OH minus equal 1.0 into 10 to the power minus 7 moles per liter. Means we know the H plus concentration at 25 degrees Celsius, but here it is not given in terms of concentration. We have to calculate in terms of numbers. Okay, in terms of number we have to calculate. So this with help of mole concept, with the help of mole concept relation, we can do it. Pure water is given, and that is also given at 25 degrees Celsius. So at 25 degrees Celsius, pure water means H plus equals nothing but OH minus equals 1.0 into 10 to the power minus 7 moles per liter, or capital M. But here we are discussing about hydronium. Hydronium nothing but in the place of H plus we can write H3O plus. Means H3O plus concentration is 1.0 into 10 to the power minus 7 moles per liter. So M, what is the M means? We know that H3O plus concentration equal 1.0 into 10 to the power minus 7. Capital M means that is actually moles per liter. So with the help of this statement, we can write with the help of this formulation, we can write 1 liter having 1 mole of H3O plus ions. Moles per liter means 1 liter is having 1.0 into 10 to the power minus 7 moles of H plus. Okay. Means 1 liter means it is given in terms of milliliter. So we have changed that liters into milliliters. So in plus we can write 1000 milliliter of water. 1000 milliliter of water has how many moles? 1.0 into 10 to the power minus 7 moles of hydronium. Then what about 10 milliliters? 10 milliliter of water has how many moles of hydronium ions? Okay, so finally we will get that is a 10 to the power minus 5 moles of H3O plus ions. Is this the answer? No. So here we got in terms of moles. Actually in the problem it is given in terms of number. In terms of number of molecules find out, number of ions find out. We got the ions in terms of moles. Find them, convert it into moles. Okay. Sorry, it is so 10 squared comes minus 2, it becomes 10 to the power minus 9 moles. Means so again make it is a second step. Okay. 1 mole of H plus or 1 mole of any compound equals, okay, 1 mole of hydronium ions equals, what is the number? Avogadro number 6.022 into 10 power 23 ions. Then what about 10 power minus 9 mole of H3O plus ions means how many ions in terms of number? Okay. So on this calculation we will get 6 point. Sometimes we can take 6 also based on the calculation. It's 9. The mole of 9 will get 14. Okay. Hydronium ions. Okay, this is the number of ions. This is the moles of hydronium ions. Okay, see one more problem. So let's see. Calculate the dissociation constant. Calculate the dissociation constant of water at room temperature. Okay, so here it's somewhat different problem. So we know that dissociation. So dissociation means decomposition into ion. This is ionization also. It forms H plus and OH minus. And we know that dissociation constant nothing but water dissociation constant, or we have to write the equilibrium constant for this. Okay. So therefore we are taking it as a dissociation constant as a Ka. Okay. So K equal to, we can write the equation H plus OH minus and H2, and with this again we can write actually we have to find the Ka. We have to find the Ka. So substituting this Ka equal to, we know that H plus into OH minus at room temperature. So what is H plus into OH minus? We can write Kw by the H2O concentration. The H2O concentration so the Ka equal to, so we know the Kw value. So Kw value 1 into 10 to the power minus 14 moles square per liter square. Here main important, what is the H2O concentration at room temperature? So we have to take the H2O concentration in terms of molar concentration. Molar concentration terms lo we have to take as 55.5. Okay, we are calculating for moles per liter. Moles per liter, if you calculate, we will get 55.5. It is only the important, the different thing in this problem. H2O concentration at room temperature, we have to take it always. This is a constant, we have to take that 55.5 because nothing but it is moles per liter. Moles per liter, because 1 mole means 18 grams. 1 liter means weight by molecular weight. Molecular weight. So weight by molecular weight and in 1 liter. So in 1 liter we will get 55.5. Okay. So on calculating 1000 by 18. Okay. So here we get so 1000 means it is a weight of 1 liter mass. Weight of 1 liter. Weight of 1 liter water. Mass of 1 liter water. Water density, we know that 1 milliliter. 1 gram per milliliter. Means 1 gram into 1 milliliter. Not simple. So 1 means 1 milliliter unte automatically 1 gram. So here we are calculating 1 liter for 1 liter kabatti. So 1000 milliliter it is 1000 grams. This weight by its molecular weight. So on this calculation we will get 55.5. So finally we got the Ka equals, so on this overall calculation we will get to 1.8 into 10 to the power of minus 16 moles per liter. This is moles square per liter square. This is moles per liter. Moles per liter get cancelled. Finally we got moles per liter. So writing the units are also very important in these problems. Okay. Okay, we'll see the next one. You see the degree of dissociation. The degree of dissociation alpha. Alpha of a weak acid. Of a weak acid. So name is not mentioned. Simply it is given HA. In 0.1 m solution, in 0.1 m solution is 0.06, not 06, it is 0.006, means alpha is given, concentration is also given. The question is how the value of alpha changes. Varies for HA in 0.05 m solution. So here the comparing the concentrations, comparing the same solution. So whatever the acid, some X acid, the given is HA acid. We have to know the relation, because at particular concentration its alpha is given. We have to find that alpha at other concentration. We know that alpha also depends on the concentration also. But how it depends on, how alpha depends on the concentration, we have to get a formula for it. So we know that Ka is equal to, we have already discussed the formula is K is equal to C alpha square. So K, there is no change in the K. It is always constant for an acid. Acid dissociation constant. Actually, we have to get the relation between C and alpha square. So with the help of this, we can write what is the alpha square equals. We can write K by C. We know that K is a constant. K is a constant, that's why we can write this removal of concentration, removal of this constant and is equal to, we can write alpha square is directly proportional to 1 by C. So if two terms are present, we can write alpha 1 square by alpha 2 square is equal to, we can write C2 by C1. So these two you have to remember as the formulas. Okay. So now see the problem. So what is the alpha 1? Alpha 1 given is how much? 0.006. What is the first concentration? So that is taken as 0.1. So I have to find the alpha to change in the alpha value at C2 concentration. What is the C2? 0.05. So just substitute in the equation 1. Just now we derived this formula. Means with the help of all the known relations, we have to create some formulas just at the time instantaneously giving the details in question. Okay. Okay, substitute in equation 1. So alpha 1 square. Alpha 1 square means there is a 0.006. We have to know the alpha 2. Okay. What is the C2? What is the first concentration is given 0.1. So I have to find that for alpha 2 square equal to so we can write 6 into 6, that is 10 power minus 3 minus 3 minus 6, 0.1, we can write 10 power minus 1 by 0.05. So 2 square equal to 36. This is 10 power minus 6 minus 7, this is minus 8 minus 9. Okay. So therefore alpha 2 is equal to root of 36 into 10 power minus 9 by 5. So alpha 2 equal to, so actually make it 36 into, this is 10 to the power of minus 9 . So on this overall calculation, you have to do the calculation. With some simplification, we will get alpha 2 equal to 0.027. So in this problem, main important is to get the relation between C1, C2 and alpha 1, alpha 2.